Hello, I'm Scott Grinke. I'm the Polisher Products Manager here at Entrepix, and today I'll be overviewing the Entrepix head tester. This head tester is capable of testing heads in the 150, 200, and 300 millimeter diameter. In this video, I will be discussing the hardware, software, safety features, and diagnostics capabilities of the tester. Starting from the rear of the machine, you'll see the AC connection, capable of 100 to 250 volts, 50 or 60 hertz, making it compatible with all US and international AC power variations. The next connection is the Ethernet connection. This connection is not mandatory to be used, but is available for interfacing with your fab's quality tracking systems. The last connection is for incoming gas. We recommend using N2, but CDA is also acceptable. The recommended incoming pressure is 90 psi, and it will operate anywhere between 70 and 150. Moving to the top portion of the tester, you will see an optical safety lid switch. During any time of operation, if the lid is detected as open, the tester will go into a safe condition by releasing all zone supply pressure and flashing a red lid open alarm text on the operator service screen. Looking closer at the lid, you will notice that it's transparent, allowing you to view the testing sequence in real time. The lid is divided into two layers. The bottom layer is removable for use in testing the 300 millimeter polishing heads to accommodate the extra expansion requirements during the zone inflations. Moving on to the front, starting at the upper left is the USB thumb drive connection. This, along with the previously mentioned Ethernet connection, can be used for test data retrieval. The green button just below is the operator safety start button, which I'll explain more about later. In the middle is the GUI, or the graphical user interface. The GUI is a high-resolution, full-color touchscreen with low ambient reflective light glare protection. On the far right is the red EMO button, or Semiconductor Industry Standard Emergency Machine Off button. Moving below the machine, here we have a sliding door for your convenience for storing tools and the data thumb drive. Here along the left side hangs the blank off, or the head interface sealing fixture. This is used for testing for internal leaks on the head tester and is used during the calibration on initial setup. Let's look back at the graphical user interface and the software operations and features, starting with the user login. There are three login security layers: Administrator, User 1, and User 2. The administrator can perform all possible functions for the head tester, including security passphrase modification, offset modification for calibration purposes, as well as incrementally and fully automated testing step by step while in semi-automation mode. User 2 will have the same capabilities, but without permission to change login security codes. User 1 may not change security information nor run test sequences in semi-auto mode, and is restricted from the manual operation screens. Once logged in from the main menu screen, you can choose to operate in manual testing, automated head testing, or the maintenance screen. Let's begin by going into the automated testing. From here, you will be prompted to select the configuration of the head type you're using. Today we will be testing the Titan head. Once you've selected your configuration, you'll want to set up your testing parameters. This is accomplished by selecting Configure. The parameter screen is divided into several sections, allowing you to customize the zone pressure set points, the allowable leak pressure delta, and the leak check duration. You can also customize the number of pre-test head pressure cycles, the zone pressure values, and customize the wafer present or wafer absent sensor verification test. In this situation, we have a wafer absent sensor. As you can see, the wafer absent sensor is highlighted in blue. If it was wafer present, we could select that, and it would move the highlight to the appropriate section. This brings us back to the main screen. As a safety feature, it requires a two-hand start. The first hand depresses the start button on the front panel. That will prompt you to hit the start button with your other hand on the software GUI. Once it's depressed, it will begin its automated routine for the pre-cycle and prompt you for a serial number. In this case, we will give it a simple serial number of Z006, and it will remember that and keep the data associated with that serial number throughout the testing. The tester begins by completing the pre-cycle testing, exercising each zone independently. It has now moved on to the pre-test vacuum cycle. You can see the status of the test at any time looking at the dialog box located here. Once the pre-cycling is completed, the head tester will start testing each zone under pressure independently, beginning with the retaining ring pressure. As you can see, the tester is inflating the retaining ring to approximately 12 psi. Once this pressure is sensed as stable, it will seal or isolate the zone for delta pressure test leak over 30 seconds, as configured in the previous screen. Once the final valve is indicated as activated, it is isolated. It is now that the machine looks for delta over the 30 seconds. This process will repeat for the other remaining zones of the head. Once all the zones are tested for pressure, the tester will then go into a vacuum mode and test for vacuum over the duration of the 30 seconds as well. Once the leak testing portion is completed, the machine will prompt you to load a wafer onto the head, and it will begin the wafer present, wafer absent testing. Upon completion of the testing, the data screen will display the passing results with a green backer. As you can see, for the pressure testing, we were within the 0.1 requirement of delta over the 30 seconds, which with no leak indicated on the retaining ring, a 0.02 on the inner tube, and 0.01 on the membrane. The vacuum side also is indicated here with a passing requirement of 0.5 or better. We easily pass with a 0.1, 0.09, and a 0.14 leak delta. The final indicator is the wafer present test result. And this is indicating that the inner tube held a positive pressure during the duration of the test, indicating a passing wafer present sensor. And then simply hit the manual start button and the software start button using both hands. We've already entered the serial number, so we'll just click OK there. And then you'll see it here. It'll exercise through all the automated functions that we had highlighted on the previous video. So here it's showing that the beginning value for the pressure test was 4.92. The end pressure was 4.43, indicating a result of greater or 0.50, which is well beyond the 0.1 requirement for pressure. When it noticed this alarm, it aborts the process, so all of your other variables remain at 0. Now you would go into your manual screen and you could troubleshoot this section independently and look for crosstalk between the other zones. You can now collect the test results using the USB port. From the main service screen, select Maintenance. From here, select Copy Files. The tester retains all data indefinitely, so you can go back at any time to recollect this or any other head results. Once you've selected Copy Files, it will copy the data onto the USB drive or send it out and make it available on the Ethernet port located at the rear of the tool. With a failing head present, let's next look at the manual zone testing and the diagnostics capabilities. From the main screen, select Manual Testing. In the manual testing screen, you will have manual control all over all the pneumatics within the tester. This screen allows you to manually test each zone independently and monitor each zone in real time. On the screen, you will see a pneumatic flow diagram. This diagram is live and will allow you to control pressure, vacuum, and control supply valves going into each zone. As a quick demonstration, I will activate the retaining ring zone on the polisher head. Start by depressing the auto mode button. This will make all of the diagnostics on the screen alive. Next, select the regulator and put in a value. For this demonstration, we'll select 9 psi. Next, press pressure. You will see in real time the valve come live that's supplying the pressure and the indicator from the transducer feedback that we are at approximately 9 psi. In order to test for leaks within the zone, select the isolation button. You'll see upon selection of the isolation that the valve becomes live, and then we can turn off the supply pressure by depressing pressure again. The pressure is now captured in the retaining ring zone of the head, and we can watch the transducer feedback over the duration of 30 seconds and monitor for a leak. As you can see, after the duration of 30 seconds, that the transducer indicates that the chamber is holding pressure, with a very small, if negligible, leak indicated. Next, we'll test the membrane zone in the head. In this case, we will select a pressure of 5 psi and select pressure again to inflate the zone. As you can see, the pressure has reached the 5 psi and can now be isolated. Upon removal of the pressure and in isolated state, we can monitor this pressure falling rate over the next duration of 30 seconds. After the 30 seconds, you can clearly see from the isolated chamber that it is leaking with a passing of greater than 0.1, which is the limit. You know from this point that you need to troubleshoot the membrane section further within your head build. So now we're just monitoring for a leak on all those zones over whatever duration we decide is appropriate. We're also actually checking for some crosstalk, because if you notice here, the retaining ring zone is set for, it's approximately at 10.8 psi, and our membrane is at 4.90. If there was a leak between these zones going from here to here, you would see that the retaining ring would be losing pressure and the membrane would be gaining. Since we're not seeing that, we know that there's no crosstalk. Now, you could go to a more extreme test here, and you could open up the isolation, allowing the retaining ring to vent if there was a leak between these two zones, or you could even select vacuum on the membrane and look for a drop in pressure on your retaining ring, right? So here it's showing that we have the negative 5.5 psi on the membrane, but yet we're still retaining the 10.86 volts, or PSI on the retaining ring. Upon completion of the leak testing diagnostics, if, for example, if you had failed for wafer present, wafer absent, we also have a screen that will help you diagnose that particular portion. Moving back to the main testing screen for your head, we have a button that's available for skip to wafer present, wafer absent. This would eliminate the leak testing portion of the test and move you directly to and prompt you to place a wafer onto the head for testing the wafer present, wafer absent portion. As you have seen, the Entrepix head tester has a lot of testing and troubleshooting capability, allowing the operator to see all the pneumatic functions in real time, which enables greater troubleshooting ability. The manual operation empowers the service personnel to efficiently drill down within each zone of the head and truly find the root cause of failure. Having this highly customizable parameter settings allows the testing at various zone pressures that can be matched to the actual production process recipe. Thank you for taking the time to watch this video demonstration of the Entrepix head tester. If you have any questions, please contact Entrepix. We look forward to doing business with you soon.